Hi. Parallel no grams, parallel yes grams. It's me pretending to talk to my grandmother, known as Grams. Parallelograms have a lot of fun facts. Opposite sides, not only are they parallel, they're congruent. Opposite sides congruent. But another fun fact about parallelograms is that the diagonals of parallelograms bisect each other. That means they cut them into two equal parts, or they cut them in half, whatever works for you. So there's a lot going on here with parallelograms, and we'll just go alphabetically. There's no reason not to go alphabetically. We have 5x over here. I have a y and a z. So like I said, let's start with the 5x. 5x is over here at QT. Oh, how about that? A side named after me, which happens to be congruent to RS. So this isn't going to be that pleasant, but that's all right. 5x is going to equal 27. So in order to find x, you divide both sides by 5, and you get 5.4. That one's fun. There's my x. Okay. Y. How do I find y? Let me get another color up here. Y is this line, which happens to be attached to another y, which is also that line. Oh, this is a parallelogram. And this is a diagonal. And that diagonal bisects these guys are the same. So let's set them equal to each other. 2y minus 5 is going to equal y plus 4. Subtract y from both sides. We got an equation. I'll just keep the same color. We got an equation with variables on different sides. So let's subtract y from both sides, and look at that. 2y minus y is just a regular y. So I've got y minus 5 equals positive 4. Y equals 9 when you add 5 to both sides. So y is 9. That wasn't so bad. Y is 9. But we have a z there. We have a z left over. Now, this doesn't come from any brand new theorem. This comes from the fact that if you have two parallel lines, and the parallel lines I'm going to look at are QR. Boy, that was almost as nice of a straight line as I've ever made. That's parallel to TS. What you have is considered a transversal in QS coming into contact with that. So if QR and TS are parallel lines and the diagonal here is the transversal, then these guys are going to be considered alternate interior angles. And alternate interior angles are equal to each other. So 3z is going to equal 33. I'm going to divide both sides by 3, divide both sides by 3, and z is 11. Now they put that 95 there to scare you. Don't be scared. Don't be scared at all. A lot of times with parallelograms, if things look the same, more often than not, they are the same. You can't always say that, but more often than not, I mean, 3z is acute, 95 is not. Speaking of acute, I have to say goodbye now. That's twice in one video. I mentioned that joke. All right, that was great. Bye.